So now I'm ready to create the least squares regression line. What I'm going to do is right click on any ordered pairs. Again, let's click here just to show you something. I'm going to put my mouse over an ordered pair shows up. Then I'm going to right click and it says add trend line. And this window appears. Now if you're using an earlier version of Excel, you'll do exactly the same steps. The only difference is in this window that appears. Yours will be separated into two parts. The first window you see is this top part, and you'll notice that the default selection is linear, which is what we want. Here are other possible regression models. And now what I want to select here at the bottom is display R squared, which we already figured out, but it'll be nice to do. Display equation on chart. On earlier versions of Excel, you'll have to click on the other tab. There'll be two tabs. One will be showing you this region. When you click on the other tab, it will show you the bottom region. And again, you will just do the same thing. Check off display equation on chart. Now I'm going to hit close. And here's the equation. Now for some reason it dumps it right in a place where you can't see it, so immediately I'm going to go to the middle of this, click on my mouse, and as I'm holding the mouse button down, I'm going to drag this so I can see it. And there's my least squares regression line. This is a statistic. This part right here, this is y hat. It's a predicted value. This is my slope. This is the y-intercept. Now, for the next step, the idea here, what we want to do is be able to predict the number of games won. But in reality, again, remember what the model is. This line is nothing more than the mean for a particular batting average. So what this thing is really producing is an average. So I'm going to come over here and I'm going to click on this column and I'm going to write predicted. So now what you need to remember is this, that the equation produces the predicted values. These here are the number of games won, but this is observed. All these numbers were observed from data. These will also be number of games won. As a matter of fact, to make it clear, I'm going to click back here and just add predicted games won. This is the actual games won. So what I need to do to predict the number of games won, I'm going to use this batting average and put it inside this equation, and for this batting average the model will let me know what it predicted. So I'm going to type here equal to, then I'm going to look at the slope. It was 746.03 times, and then since I want to automate it, I want to find it for all of them, I'm going to put in the position of this batting average, which is B2, and I could do that by just clicking on B2 and then plus, and I see a negative 122.89. That's the y-intercept. So I'll hit return, and here is the predicted number of games won, which is 75.55. So for a batting average of .266, it's predicting that the team will win around 75, 76 games. Now to get the rest, I'm going to come over here to the lower right hand corner, and the computer will now do the same thing. It will put each batting average into the equation and produce the predicted values. So these are all predicted values. So for example, if a team is batting .263, what is it that we predict should be the most likely number for the team batting average? This would be it. Sorry, the number of games won. This value would be it. So here we would predict a number of games won to be about 73. We actually observed 72, but the model's predicting around 73. Again, this is individual observations. One way to view this is that these are the means, the means of the situation where the team batted 263. So if another team batted 263, of course the number of games won would be above 73, maybe below 73, but we're hovering around 73. And of course this is only a predictor, so this is like the chapter 6, section 1 of your text of X bar.